Welcome to an epic podcast on the proof of L'Hopital's rule, the infinity over infinity case. And this basically says if g goes out to plus or minus infinity, we'll be assuming it's plus infinity for this case, then f prime over g prime limit equals L implies f over g the limit equals L. And we're just going to prove that this is true if the limit approaches from the right, but the proof is similar if you want to prove that it works if it approaches from the left. So the way we prove it is we let epsilon be bigger than 0. And I have three pictures here. Those three pictures are because we're going to have three deltas. So I'm going to start off by looking at delta 1, which is basically where the proof starts. There exists a delta 1 such that basically I'm using the fact that the limit of the derivatives equals L. F prime over g prime minus L is less than epsilon whenever x is between a and a plus delta 1. Remember, it's just a one-sided limit. And this is the variable we could call t. So the picture of this looks like, here's my t, which equals a plus delta 1. And then what I'm going to do is I'm going to pick any value for x in here that I want. Pick any x you like. And then you get that this equation is true. Well, now what's going to happen is I'm going to fix these two, and I'm going to apply the generalized mean value theorem. And when I apply the generalized mean value theorem, I get f of x, this is from the generalized mean value theorem, f of x minus f of t over g of x minus g of t equals f prime over c, or f prime of c over g prime of c, over for some c in this interval between x and t. So the way this picture looks is, in orange, I have some sort of a c in here such that that's true. So for the remainder of the proof, we're basically going to take x to be fixed, where x can be anything between in this interval. So my goal is I'm going to show that f of x over g of x is less than epsilon. F of x over g of x minus L is less than epsilon. That's how I'll know when I'm done. And I'm going to start by using this. Because I know that this c is between a and t. So it's between a and t. So that means that f prime of c over g prime of c minus L is less than or equal to this. Which implies that L minus epsilon over 2 is less than f prime over c, g prime over c is less than L plus epsilon over 2. But what's going to happen here is I know that f prime of c over g prime of c is equal to this thing. So what I can do is I can erase what's in there, and I'm going to replace this part right here with this quotient right here. That's a perfectly legitimate thing to do since they're equal. So I'm going to replace this as soon as I get my pencil back. There we go. F of x minus f of t, where t is fixed, remember, over g of x minus g of t. And notice that this was true for any x I pick. Any x in this interval, I'm going to get a c, and so I can apply this logic. So now x can actually be anything that I want, once again, as long as it's between a and t. So I'm going to get this, and I'm going to work. My goal now is I'm going to work to basically isolate this right here. Well, how am I going to do that? You know, I think that's going to be the subject for the next podcast, because I only have about 45 seconds left. So I'm going to stop here, and I'm going to resume with the second podcast.